Hello everyone, I'm very excited because I found this interesting problem here. I to the power I is equal to what? I'm going to be talking about everything you need to know under this problem. But if you're new on my channel, subscribe to my channel, like the video, comment, and share. Now let's get started. If we have a which could be written as e to the power ln of a, then it means that we can write I as e to the power ln of I. Very interesting. Now let's allocate this I to the base here. So the problem now actually becomes e to the power ln of I or to the power I. Now let's record this power rule that if you have a to the power m or to the power n, we can write this as a to the power n or to the power m. So it's a matter of interchanging their positions, right? So our problem now becomes e to the power I or to the power ln of I. But the question is, what is ln of I? This is where the problem becomes interesting. Now let's go into the complex plane. And as always, the horizontal axis becomes the real part, and then the vertical axis becomes the imaginary part. Now let's say the distance from the origin to this point is b, and then the distance from the origin to this point is a. Now, if you trace this one just like this, and then this one just like this, at their point of intersection, let's call it z. And in complex plane, z is going to be a plus bi. Great. If we draw a straight line from the origin all the way to point z, then we're going to have our r here. Then r has created a certain angle. Let's call that angle theta. Let's go ahead and then resolve a along the horizontal component. So we're going to have, let me change the marker. We're going to have a is equal to r cos theta. Then if we resolve along the vertical axis, we're going to have b is equal to r sine theta. Now let's go ahead and then replace this a and b into this equation here. So we're going to have z is equal to a, which is r cos theta, plus b, which is r sine theta. Actually, we have I here, so let me bring this I here. Now let's go ahead and then factor out r so that we get r times cos theta plus I sine theta. Now guess what? What is in the parentheses here is equal to something. Euler's formula. That is great. Euler's formula is given by e to the power I theta, which is equal to this whole thing, right? So from here, we just have r here. I'm going to bring the r here. Then this is equal to z. Let's call this equation 1 or equation star. That is great. Then from here, we're going to take ln on each side of the equation. So we're going to have ln of z is equal to ln of r e to the power I theta. Now, we can have ln of z is equal to, this is natural log, so we're going to split this one. So we'll have ln of r plus ln of e to the power I theta. And now we have ln of z is equal to ln of r plus, now we see that this ln and then this e will undo each other. So here we are left with I theta. So this is the equation that we have. Now let's go back to our main problem right here. With this one, we can just find what ln of I is using the equation that we just found. So we're going to have ln of I to be equal to ln of r plus I theta. Now let's represent this on complex plane. And as always, when you talk about complex plane, this one now becomes the real part, and then this vertical axis becomes the imaginary part. Now this point here is going to be 1i, so it means that the distance from this, or the distance from the origin to this point here, will become 1, which is equal to our r, and here is our I. Then the distance from the origin to this point now becomes 1. Now what about theta from here? Theta is actually the distance from here to this point here, which is 90 degrees. In radian is going to be pi divided by 2. But the truth is that we can keep on rotating just like that in so many ways. So we can have so many angles for theta. Therefore, it is important to add 2n pi, where n is an integer. That is great. Now we know what r is, we know what theta is. So let's go ahead and then replace them in this interesting equation here. So we're going to have ln of I is equal to ln of r, where r is equal to 1 from here. So we're going to have 1, then plus I times theta, and theta is giving us the whole of this one here. So we're going to have I times pi divided by 2 plus 2n pi. Now let's simplify this further. We have ln of I is equal to ln of 1 is technically 0. So we have 0 plus, now let me get rid of the 0 and then add what is left here. We're going to have I pi divided by 2 plus 2n pi. So this is what we have for ln of I. So let's go ahead and then put it into this expression right here. So we're going to have e to the power I times everything here. That is I times pi divided by 2 plus 2n pi. Now guess what? I times I is -1. So we will have e to the power -1 times pi divided by 2 plus 2n pi. And if you like, you can just end it here, or you can distribute this -1. So if you do that, we're going to have e to the power negative pi over 2 plus, minus 2n pi.